EDA, I don't think we use this a whole lot, but I would write it down. But EDA, if you ever see that in the book, exploratory data analysis. All right. So EDA, exploratory data analysis. That's just what we're doing with all this when we're taking this data and we're exploring it and analyzing it. Just a big fancy term that some math person wanted to stick in there to make it seem like they were intelligent. So Sean can go home tonight and tell these folks, we talked about exploratory data analysis today. And they'll look at him like, what? Right? That makes it seem like you're real smart, and then you get low.
My parents looked at me like that the second they
Your
started
parents,
talking.
I know how your parents look at you. They look at you. Really? You came from me. That's how they look at you.
Stepmom's head in that team. My stepmom's head in that team last day.
Oh, really?
Yeah,
So you probably can't say that. You'll go home and say, and she'll go, oh, so you're doing this and this and this, and you'll go,
I don't even know what that is.
and then you'll, so you'll be the one walking away. All right, this you should write down. And you might just title this, just graphs probably. So if you just title it graphs, that'd be the title of your notes today. I don't know that you really need to write this down, but just put a title on their graphs. Besides histograms, there are other methods of graphing quantitative data, stem and leaf plots, dot plots, time series, and I should have read this before I said write it down, because we're going to write all this down as I explain to you what a stem and leaf plot is, what a dot plot is, what a time series is. And I know this is like, what's it called when you do something against a religion? Sacrilegious, is that what it is? Sacrilegious, but I gotta turn this. I know here in Preble County, if you turn off this song, it's something bad, right? It's not. And we all should be doing what right now? Standing and Mr. Miller, isn't this the theme or the national anthem for Preble County?
Well, let me turn it off. It's crazy.
All right, a stem and leaf plot. Stem and leaf plot represents data by separating each data value into two parts. This you might want to write down. This is the definition of a stem and leaf plot. The stem, such as the leftmost digit, and the leaf, such as the rightmost digit. Sorry, I don't know if that should be separated there or not. My typing's not the greatest. I think this. Well, I'm not. It's got something else up here. Sometimes I know what I'm doing, Greg. That's what a stem and leaf plot looks like. All right, so you break off your stems and you have your leaves. And I'll explain, I'll give you a second to write it down, and then I'll sort of explain it. You've probably seen it before, so it'll be something real quick we'll go back over. Might as well walk through this stuff you should get. I swear to goodness, I've never had a pair of shoes that looked that new. I don't know. Apparently, when I walk out of the store or something, they get dirty in the box or something as I'm walking out, because I've never had a pair of shoes that look that new.
These are like 3 weeks old.
See, Grant's shoes look more like mine. What? See, you're saying that, and guess where these pants probably came from? Guess where this shirt probably came from?
I think we've all been there.
No, you'll be there even more when you have
Like 5 kids.
3 kids and a wife, because they get new stuff, and you're out of luck.
I haven't kids. I ain't getting married.
That's a good idea.
Pardon me, teachers, for the interruption. The following students need to meet the high school office. Brooke Updegraff, Erica Gallagher, Michelle Massa, Hunter Lee, Travis Hunt, Mallory Nugent, and Gracie Jones. Thank you.
All right, stem and leaf plot. Stem and leaf plot, what you do, you'll have a list of numbers, and this list that they gave us may have looked something like this. And they'll probably be in numerical order. If they're not in numerical order, you need to put them in numerical order, and we'll talk about that here in a second. But this stem would have looked something like this. So on, so on, so on. And you just got to decide, how can I split these numbers up? And in this case, it's pretty easy when you have just numbers that are in the tens, like 60s, 70s, 50s, 40s, whatever, because we can just make that your stem, and then the second number your leaf. So this 6 and this 4 right here go together to make 64. This, let's jump way down here, this 1, 2 stem goes together with that 0 to make 120. Yeah. All right. Notice what values did we have in like the hundreds, 110s range? There wasn't any. All right, but we still need those stems in there to keep it uniform. We want them in numerical order. Here in a second, one of the slides shows an unordered stem and leaf plot. Don't ever do that. That's a waste of time. If you unorder it, then you might as well have left it as the list, because it doesn't help anything. You'll notice if we turn this stem and leaf plot sideways, we could do something like this. Now all of a sudden it looks like the histograms that we were dealing with last time, if you turned it, and that's sort of what a stem and leaf plot is. It's still giving you all the numbers, but it shows you that, hey, there's a whole lot more in this range, in that 70s range, than the other ranges. Or everything's in the 70s or 80s. Most of it's in that range. So it's sort of like a histogram, but with the numbers still in it and going sideways instead of up and down. Sometimes it's sort of hard to use a stem and leaf plot. I mean, if you got numbers that range from something like 150 to 3,000, then you're getting into where a stem and leaf plot might not be the best thing to use to show the data, to show your information. Each number is separated. Stem and leaf is saying the same thing. Just to explain it to you, if our data was 21, 25, 25, 26, 27, so on and so on, these are our stems. These are our leaves. And we just look through here and we can pick out, okay, that goes with 26, so on and so on. Now the one thing on this stem and leaf plot that you must always have, and I should have said this on the other one, is you need a key. So you're always going to have a key and explain to somebody that, hey, 2/6, so the 2 on this side and the 6 on that side means or equals 26. Because sometimes you might have this list and instead of 26, that 2/6 might mean what? 2.6, and you could split it up there at the decimal. So you need that key so that you know what you're using, what each one stands for. What's that tell us? 36. Which number appears the most in this set of data? Or 25, they both appear twice, right? What's the lowest number in that set of data? 21. What's the highest number? 45. So if we were going to find the range like we had to do the other day, 45 minus 21, you could do all that stuff. When it's in order like that, that's real helpful. Similar to histogram, we already said that. Still contains original data values. Constructing a stem and leaf plot. It's not hard to, if I was gonna write this down, maybe just write those two things. Split the stems, or no, not those two things, sorry, that's the wrong thing. I was thinking of the next range all possible. Do you guys need, it's not that hard to make a stem and leaf plot, right? So, there's no reason to write down all this. This is the one thing you might wanna remember. 5 to 20 stems. If you get more than that, like I said, with that 150 to 3,000, if you got more than 20 stems, it's a waste of time then. It's not gonna tell you anything. Two other kinds of stem and leaf plots that we might deal with at some time. If you have split stems, what that means is in your stem and leaf plot, when you have your stem out here, instead of going like 1, 2, 3, 4, it might go 1, 1, 2, 2, 3, 3, and that's if there's a lot in certain groups. So then the first one would be like from, all the 10s to 15, so maybe all the 0 to 5s in there, and then the second one would be all the 6s through the 9s or something like that. So we would split up the groups so that they're not so long. A back-to-back stem and leaf plot, a lot of times when we're comparing males to females or dogs to cats or comparing two things that aren't really the same, we'll have a back-to-back stem and leaf plot, and it looks like this. Your stem will be in the middle, then you have a leaf over here, and you have a leaf over here, and maybe this leaf stands for the females, this one stands for the males, and you do your 1, 2, 3, whatever your stems are down through there, and then you'll have the male information over here and the female information on this side, and you can sort of compare the two and say, oh look, the females are a lot in the 20 range, the males are a lot in the 10 range or something, and then you can sort of compare the two things that aren't really the same. Following are numbers of text messages sent last month by cellular phone users on one floor of a college dormitory. Display the data in a stem and leaf plot. And we're just going to run through this real quick. Notice you have this big long set of data. It's not in order. So when we put it in the stem and leaf plot, and this is sort of hard sometimes, and we've seen this when we were doing the list last time because we missed a number, then figured out we missed another number and missed another number, right? We missed like 4 numbers that last time. So what you got to do is just go through here, and it looks like what, 78's the lowest. So go through and you figure out your lowest, and then put it in your stem and leaf, and just have to go through it. And probably you're going to mess up at least once and have to stick another number back in there or something. But just be careful. What do you think our stems would be here? 7, 8, 9, 10, 11, 12, right? You probably use that as your stems. 7, 8, 9, 10, 11, 12. Sorry, Dalton, that I'm talking over your song, but we got to move along.
It's a whole new world.
And then I could see you over there mouthing it, getting ready to sing. We'll have you come up here in a minute and sing it to us. So the stem and leaf plot looks like this. We use, like Dom said, use 7, 15, use those as our stems. Come on. So stem and leaf plot would end up looking like this. Again, you need a key in there. They actually show 2 different ones here. They show an unordered and they show an ordered. Don't ever do that one. It doesn't do any good to look at this and have it unordered, because the whole purpose of the stem and leaf plot is so you can find the lowest number, the highest number, and you can see which numbers occur the most and the ranges that occur the most. So that's the one you want to do. But again, what most people forget is the key. I know Dom wants me to go back, he wants to hear the rabbit from Alice in Wonderland again, right?
That's what it was.
I think that's what it was, wasn't it?
I don't know.
That's what it was.
What was that?
Outliers, might wanna write this down, an outlier. What's an outlier? It's not a person that lies on the outside either. Numbers that what?
That don't fit with the rest of the.
Alright, they don't fit. Like on that one that we looked at, you had that 120, that would probably be an outlier. Now in the past, when you had outliers, if you were doing something with the graph or something and they asked you to tell what the outliers was, you probably just looked at it and figured out, oh yeah, that's an outlier because it's way out there compared to everything else. There's a mathematical way to figure out what outliers are, and we're gonna talk about that as the year goes along. With that, what we're gonna do, and probably what I will do in here on your test, is most every test that we take, I'm gonna grade on a bell curve. That's what a bell curve looks like. This is what a lot of college professors do now. In this bell curve, you have this middle section. Guess what grade that is? C. Why a C?
That's the middle.
That's supposed to be average, right? In that middle range, a certain percentage falls in there. It's like 30%. It's different than that, but that's what we're gonna go with now. Then you have these two ranges over here. B, A. Then down here. And with the bell curve, what has to happen is you have to have somebody in every range. So let's say on that last test that we took, there was 42 possible on the test, and let's say everybody scored 38 or higher. Well, even though 38 divided by 42, if one of you grab your calculator, what's 38 divided by 42? Figure that out for a percentage for me real quick. 0.9 what?
9048.
So about 91%. So you'd scored a 91%. With a bell curve grading system, even though the lowest grade was a 38, guess what that lowest grade, guess where it would fall in here? It'd be the F. So you'd have a 91% and you would be here. Alright? So with the bell curve, what you have to do is you have to separate it so there's like 30% here, 20% here, 20% here, 15% here, 15% there, 70, 30, I think that's right. So no matter what, there has to be 15% in that F range, 20% in that, 30, 20. Hope no other math teacher ever watches this because those percentages are all completely wrong for a bell curve, but I don't feel like writing down the exact numbers, but it's something like that, right? And when we have outliers, my whole point of this, when we have an outlier, will be that person who couldn't have scored over here on the test that we just took. But could somebody have, we said everybody was 38 or higher, could somebody have scored a 10? Yeah, and then they would be an outlier. They'd be way out there compared to everybody else. So that's all an outlier is. And we're gonna figure out how to find those outliers later on in the year. All right, a dot plot. Might wanna write this down if you've never seen a dot plot. Maybe just draw that picture there to sort of show you what a dot plot is. Exactly what it sounds like. Draw a number line and you put dots on it. So as Sean gets done writing, he's gonna stand up, me and him are gonna do the jitterbug, right? This music back in the 1920s or something. With a dot plot, all you do on a dot plot, you draw a number line. All number lines have to start at 0. Alright, don't start everything at 0. You're going to have some great big huge. This number line is already too long. When you get over 20 numbers on there, that's too much for a number line. Start at whatever number, maybe 1 below whatever your lowest number is, maybe 1 above whatever your highest number is, and all you're going to do is go through the data and you put a dot above each one. So a dot above 21, then a dot above 25. Then we have another 25, so we put another dot right above that. And when you get something like this that has a whole bunch of dots on it, this one doesn't have a whole lot, maybe we throw some more on here. You start to notice that it could be a histogram again, right? Sort of starts to look the same. Gives you sort of the same information, the same sort of picture of it. Constructing a dot plot. So we take this set of data. We look for our highest and our lowest numbers. If I look through here, somebody find the highest for me and I'll find the lowest. 159 is the highest. Is there a 78 in there? Oh yeah, there is. I didn't see it. 78 is the lowest, 159 is the highest. So that's going to be at the ends, or towards the ends of our number line. Notice here, instead of putting all those numbers on there, they split it up into like 5s or 10s. Probably if I was doing this, I probably wouldn't have went as far as they did, because I probably would have made our number line, and I would have went like 70, 80, 90, something like that, 100, all the way up to 160. It doesn't have to be great, but you still have to be able to tell what you're dealing with. So I'm not going to ask you to make something as spectacular as this with all the tick marks on it and everything, but try to make it so that, hey, I can tell that these 3 numbers right here stand for 109. And when you're looking at this, you can probably sort of tell if they ask you to find an outlier. That number there looks like it doesn't fit with the rest of the data, right? So we consider it an outlier for now. And again, we look at all this, and if you're looking at 126, looks like it occurred the most. Looks like the biggest portion of the data fell in between 110, 135, somewhere around that range. You can just sort of get ideas where the data is represented. All right, a pie chart. Pie chart, some of this you probably do want to write down. And we're going to talk about this. This is pie chart's a little tougher because in the past you probably just drew a pie chart and you went like this. Yeah, that's going to be about that much. Yeah, we'll make that one about that much. Yeah, that one's small, so we'll make it about that much. Now you got to be a little more precise. Pie chart is a circle divided into sectors. Remember, a circle's 360 degrees. You're going to use the central angles. If you remember back to your geometry days, a central angle is an angle that has its vertex at the center of the circle. Has that corner at the center of the circle. Grant remembers that, right, Grant?
Yeah.
Did you teach anything else after that? Alright, what you're going to do, I thought this was on the video, but apparently, or on the PowerPoint, but apparently not. PowerPoint. What you're going to do each time when you're looking for this, if you're given numbers, and it might show when we do the example, You're gonna use that central angle, and you're gonna figure out what that central angle is out of the 360. So if your central angle is something like, there's two different ways you could do this depending on the information you're given. If your central angle, if we knew that this angle right here was 120, then we just change that to a decimal, and whatever that decimal is, which this one's gonna be 0.3 repeating, you take that times whatever to figure out your stuff. Most of the time you're gonna be given, and I'm just gonna go on to this, because it's probably gonna be easier. Most of the time you're given your information. We're gonna use this 728, and what we're gonna have to do is total that up, and we're gonna figure out what percentage of the circle it is. And then we take that percentage times 360 to figure out how many degrees that is. Now, when you go to make your pie chart, I'm not gonna ask you to grab a protractor up here, but if you take, somebody help me out with the calculator, what's all these added up? 7, 28, 15, 25, 604, 90, and 60.
So I got to
3007. Now take 728 and divide it by 3007. 24. So
my calculator set for the fourth decimal.
so it's 0.24. What is that close to? What percentage?
0.25.
0.25, about 25%. So we're saying when we make this circle graph, the associates piece of the pie should be about 25% of the entire circle. Well, what's 25%? A quarter, right? Is that what you said? It's a quarter. Well, if a circle's 360 degrees, what we do is we take that right there and you multiply it by 360. What's that going to give you? 90. Close to 90, right? So when we make this, that's going to be the associates piece of the pie. And you probably want to put in there 0.24. Do what? Because that's what it says that they had. Smack you. So when you're constructing a pie chart, find the total sample. This is what I was looking for. Find the total sample size. That's what we did. So add them all up. This is, you might want to write this one down. Pie chart's a little harder to make. So you add them all up. I'm just trying to make this a little easier for you to write. Convert the frequencies to relative frequencies. In other words, you see they make that big long. So change everything to a percent. Once you have that percent, multiply. It's actually, you don't want the percent, probably, you do want the percent because you're probably going to write it in. But you probably want the decimal form because you're going to multiply the decimal by 360. And when you multiply that by 360 like we did on that 24, it's going to give you the degrees. And then you can take your pie chart and say, okay, 86 degrees is about a fourth, so it's going to be something maybe like that. It's going to be close to a right angle, but not quite. Draw and label each sector. Here we put associates, and then you might put in 24%. My pen was right. Michael, any of that makes sense? You can handle all that, right? Is that brand new shirt? It's awful white. One of these days, Michael, you're gonna have to find me something new so I can wear it. All right. So main things, when you're making a pie chart, add them all up. Change everything to a decimal or percent. And you do that by just taking each category divided by the total. Take that decimal, multiply it by 360. That's going to tell you what each angle is. Then you can draw each sector in your pie chart. So if we look at this one, we added them all up. Did you guys tell me 3007? Is that what you told me? So we add them all up, we got a total of 3007. We change each one to a percent, 24%, 51%, 20%, 3%, 2%. If I'm gonna make my pie chart, put a dot right in the middle. And again, I'm not gonna look at that it's perfect. 24%, well, probably the first one I would do is this one, because that's about half, right? So I'd probably do something maybe like that, that's close enough. And that's our bachelor's. Write that in there and put 51%. Then maybe go to this one, that's about 24%, that'd be almost a right angle, so maybe something like that. That's our associates. And that's 24%.
Just watch this movie.
The new one or this one? We look on down through here, and this is about 20%. Well, if we take 0.2, somebody help me out, what's 0.2 times 360 on your calculator? Yeah. 72 degrees, is that about right? So 72 degrees. We look at the rest of this, it's a little more than 90 here. We got 72 degrees left. Then you got the 3% and the 2% if we multiplied each of those by 360. 0.03 times 360. 0, 18, about 11%. And then this last one, if that's 11%, this is probably going to be 9% or something around there, right? Who knows? It doesn't have to be exact because one of them is going to come out just that. So we'd say, okay, this one's about 72. It's going to be quite a bit of that, and then just split this one up almost in half.
It was 6%.
6%. That was a little high. Split it up like that, and then make sure you label stuff. You might have to draw arrows to label it because it's too small to write in. Next slide probably shows all that. 11%, 7%. It was 7%.
5.5 repeated.
0.02 times 360.
2 times 360.
So yeah, he doesn't believe himself.
Okay, you're right. I draw mine.
Was there ever a question? Do we need to cover that early in the year? That when there's a question of who's right, me or you? So our pie chart would look something like this.
What page you wrong? What page you wrong?
I probably just let you think that. We're not gonna go through this. Dom's getting bored with all this, so am I. Huh? I didn't say you were asleep. So you must have been asleep if you had to jump up and say, I'm awake. All right, a Pareto chart. Pareto chart, a little different on a Pareto chart. These last two, probably something new. So, a Pareto chart's a vertical bar graph. Again, not a histogram. What's different about a histogram and a bar graph? All right, the bars don't touch each other. So this is a bar graph. The lines, the bars don't touch. Histogram, the bars touch. It's a continual thing. Main thing with the Pareto chart, it's got categories, not numbers, categories along the bottom. So it might have like freshmen, sophomores, juniors, seniors. And then up the side, it's got the frequency, how often whatever we ask them or whatever we're trying to figure out occurred for the freshmen, sophomores, juniors, or seniors. And they tell you here, the horizontal axis, that's the bottom, is qualitative. So it's some kind of name or some kind of quality. Bars don't touch.
They can't.
Yeah, they can, but I'd rather they didn't. The main thing with the Pareto chart is this right here. This is what messes it up, makes it different than other things. The bars go in order from biggest to smallest. So when you go to make your bars, you always put the one that occurs the most first, then the next most, next most, next most. So unlike a normal bar graph, where a normal bar graph might look like this,
So you do it just like you did that pie graph a second ago.
normal bar graph might look like this, where the bars go up and down. In a Pareto chart, this has always got to be the tallest, next tallest, then the shortest. It's got to go in order so that it goes downhill all the way down through there.
Get a lot more involved
Does he ever stop talking?
with it.
All right, constructing a Pareto chart, just watching, we're gonna go through this very quickly because I don't think those are all that hard. To construct it, create a bar for each category. The bars are often positioned in order, not often, they're always positioned in order. With the tallest bar positioned to the left and the shortest bar to the right. That's what makes it a Pareto chart. So it's gonna look something like this so that you get that idea that, hey, this one's the one that occurs the most, and then it goes downhill from there,
It's the downhill curve.
usually. Sometimes it might, be less of a curve like that last one, and it might just go something like that. Just looking at this, if we construct this, we have this information. The one that's the most, the employee theft, that's gotta go to the far left when we make it, and then it occurred about 15.9, so over here, we put our numbers 2, 4, 6, 8, all the way up there. And when we make the top of it, then we make the bar. Doesn't have to look spectacular. Put your little tick mark in the middle and label each one. All right, paired data sets, scattered plot. Scatter plot you've probably done in the past, so it's not anything that's real difficult. With the scatter plot, all you're going to do is you have your x-axis and you have your y-axis, and I drew them backwards, but this is your x, this is your y, and it's just a scatter plot. You'll see this if you have baby brothers or sisters. If you go to the doctor's office with your folks, with your mom, and first thing they do when they bring the baby in is what? It's the very first thing. Weigh it and measure. Weight and height. And the doctor will have a chart, and on that chart it's actually got a scatter plot. Most of them now don't have the scatter plot on there. Now they just have a line of best fit. So they have that line, and then they show it to you when they get in there and they say, little Johnny falls right there on the weight chart. All right, and then they'll show you another chart, and it's got a line on it, and they'll say, little Johnny falls right here on the height chart. And then you can make decisions about it. So this kid is short, and he's probably what?
Pretty chunky.
He's pretty chunky if he's that short. And the doctor might say, you need to quit feeding little Johnny so much because you're making him, gonna stunt his growth, and it's not good for him. Or it might be the other way around. Maybe little Johnny's weight, been hearing a lot about this in the news here lately. Like 5 or 6 parents in Dayton and around the area in Cincinnati and stuff getting in trouble for starving their babies to death and stupid crap like that. And you see that little Johnny is on the chart, and his height, or his weight's way down towards the bottom and his height's way up towards the top, then he's malnutrition probably. And they look at this stuff not just because maybe you're a bad parent, but a lot of times that'll tell if the child's actually getting the nutrition they need from the formula or the breast milk or whatever it happens to be that you're feeding it. But that's what this is. So if we're looking at a scatter plot, might look something like that. It's just dots plotted all over the X and Y axes. Something you've probably seen in the past, nothing new. You gotta be able to interpret this. If I'm looking at this, it says Fisher's Iris data set, petal length and petal width. If I said I had my iris at the house and we were going to bet on the length compared to the width, or the width compared to the length, whichever, because I wrote it backwards. Could you make a good guess from this chart about what the length and what the width of my petals on my iris would be? You should be able to. Somebody give me some numbers. What do you think if I got this random iris, what do you think the width of the petal is going to be about? 15, that's a good guess. What, how about the length? 45, 50? All right, that might be a good guess. If I looked at this, that would put me somewhere out in that area. That's probably a pretty good guess that my iris has petals that length and width.
One little itty chunk, that's about 550.
So what was probably true about something like that if we interpreting this? You think maybe there was a special kind of iris that fell on this low end? Maybe a miniature iris or something that they had in there? What is an iris? Somebody help Grant out.
Oh, it's a plant.
It's a plant. So maybe there was some kind of miniature plant in there. You know, like when you plant those miniature corns out in your field instead of the big corns. You never seen that? You don't see those little miniature corns that they put in salads and stuff? And you never seen the corn plants that are like this tall out in the field? There's one outside El Dorado over there. One of those miniature cornfields. You never seen it? Go look at it this weekend. It's just Raleigh's going. She's back there laughing because she knows.
I'm not stupid.
All right, a time series. Again, you might not have seen a time series before, so you might want to write this down. All a time series is, and the main thing is this right here. And you might draw an example of it here in a second. Data set is composed of quantitative entries taken at regular intervals over a period of time. So with the time series, what you're going to have times down here along the bottom. It might be years, it might be minutes, seconds, whatever. So it might be something like 2010, 2011, 2012, so on, so on, so on. And then going up the side, you're going to have your quantitative data, your numbers. You're going to have your numbers going up the side. Maybe in 2000, it might be something like 2, 4, 6, 8. And then we just plot each one with a point. So in 2010, maybe it was 8. 2011, it was 4. 2012, it was 6, so on, so on. And then we connect it, sort of like a line plot. Connect your dots. That's a time series. Could be years, could be months, could be days, could be seconds, minutes. Maybe you're doing some kind of science experiment and you're checking something every 5 seconds. So you go 5 seconds, 10 seconds, 15 seconds, 20 seconds. You want to see where the flight of the rocket is after 5 seconds, after 10 seconds, after 15 seconds, after 20 seconds, so on and so on. That's just a time series. So a time series is going to look something like this. Notice down through here, we got the years. This is number of screens at drive-in movie theaters. If we extended this on out, it's now 2016. Somebody give me a guess. What do you think where do you think that dot would be for 2016? Think it'd be way back up here? Probably not. When was the last time you went to a, Mr. Miller, when was the last time you went to a drive-in movie? Really? You did? You guys are freak balls. Nobody goes to drive-in movies anymore. I'm just kidding. But how many drive-in movie theaters are there around? Do you guys know that there used to be one over in, whatever that little town is right across 40? New West, is it New Westville? No. Is that right? New Westville? Going the other way across 40. It's on this side of 40 actually. On, right off of, if you're coming out of New Paris and you go across 40.
That's not Westville.
New Westville.
I can't believe that, there's like 3 houses there.
There used to be a drive-in movie theater. So you go over the bridge, all right, you go over the bridge into New Westville, and off to the side over here, there's these little houses.
I know what you're talking about.
These little houses,
Because
they
no-
didn't used to be there, I think.
Noah Fudge's house is right there where it used to be.
I think these houses are like, Tom Raper houses, or like the mobile kind of houses or whatever.
The one lady with the grass roof back here.
And then there's there's this, and you got the house that's underneath the ground back here.
Yeah.
The movie theater.
With
It was right there.
bus, they got that bus.
Do they have a bus now?
Yeah, they just put an awning on it and call it home. That's awesome. They
There-
did, I swear.
There's another house back here, and this guy, and I don't know if he still lives there or not, but he works on pinball machines.
Oh, yeah,
I'm
he's-
taking my pinball
That's what
machine
Matt
there.
Tyree works.
He works for him? Really?
They're opening an arcade or something in New Paris, supposedly.
So, this used to be a drive-in movie theater. We used to go there all the time.
Because, no, Fudge, right? Noah would live literally like right on the purple line underneath the grass roof house, right there.
Right here.
Yeah, like right in front of the grass roof.
There's another house somewhere, where's it at? It's over this way. I used to know the guy that lived there. Maybe it's down this way. But it's even, this house, you know, you say grass roof, this other guy's house, cause I've been in it before, it actually is completely underground. And you can walk out, I mean, when you walk out this door, that's the only door there is, and you can walk out it and it's, everything around you is grass.
Well,
Yeah, we're not gonna construct this. So you got this, it's a time chart again, 1998, 99, be able to read these. Let's just look at this real quick. In 2003, how many subscribers were there in millions? Make an estimate.
160.
About 160 million. What's happened to the subscribers as we go through the years? It's increasing. This is for cellular phone subscribers. What if we change this? And instead of cellular phone subscribers, we said platinum item subscribers. What do you think that it would look like?
Probably went down.
It would be something more going down this way, right? Because now newspapers are, you still see them, but
I'm like 95% sure you pronounced that wrong.
platinum item.
Where'd that go?
Of your dad, and that's the wrong problem. We did that last time. That's this assignment. If you want me to do a few of them, we got about 20 minutes. I'd probably do some of these up here on the board if you'd like. If you started on it last time and you were confused, then I put it up there
What
last
do you
time.
mean by just give two?
Huh?
What do you mean by just give two?
I'll look at it here in a second. Some of them that just give two here and that don't draw for these two sections, I'll explain that here in a minute. Let's see, we gotta get rid of this, get rid of that. You know that breaks my heart, right?
What page is this on?
Page 85.
60.
Really?
I don't want to say that.
Still got a few possibilities here. We'll change mine.
You're not allowed to.
Alright, so we just have 1, 2, 3, 4.
Problems 13 through 16 says just give 2. Nick just can't take it. I know he's wanting to dance. Winnie the Pooh. Everybody likes this song. Winnie the Pooh. Winnie the Pooh. Willie, silly little bear. 13 through 16 says in exercise 13 through 16, give 3 conclusions that can be drawn from the graph. So just give 2. I don't want 3. I don't want to read that much. All right. So just draw 2 conclusions. Like if I look at problem 13, it says average time spent on top 5 social networking sites, and it's got MySpace, Tag, Facebook, My Yearbook. Some of these aren't even around anymore, right? Twitter. Give me some kind of conclusion you could draw looking at that graph. What could you say? Make up something. Can't really be wrong. I might say, I don't know that that's a good conclusion, but can't really be wrong. We will here in a second, but I want to go over these. Nobody can draw a conclusion about that?
I don't even know which one you're calling it.
Do what, Grant?
Which one are you calling?
13.
Sorry, I'm lost.
Maybe a conclusion would be like something easy. MySpace is more popular than Twitter. That's a conclusion. Now, is that a good conclusion? No, any goofball should be able to look at the graph and say that, right? Usually when we make a conclusion, we want something that's going to mean something to the next person. You might even say, this graph is outdated now because, is it going to look that way if we were to take the same information today? No. MySpace, would that be bigger than Twitter now?
That exists anymore.
I don't even think MySpace is around anymore, is it?
Just like that.
Did you? I try to not hear what you say a lot of times. Well, I think My Yearbook's still around, isn't it? Tagged, I don't even know what that is. I don't even know what Tagged is, so that might be gone too. My Yearbook, I get stuff from them in my email all the time. Somebody tagged your yearbook. I don't even have a yearbook. Leave me alone and quit sending me stuff. So you want to start on number 1? Is that what you want to do? You want to go through them together, or can I sit here and do nothing?
1, 2, 3.
Number 1. Name some ways to display quantitative data graphically. Name some ways to display qualitative data graphically. Quantitative. What kind of things did we use to use quantitative? Time series. What else? Give me at least one more. We did one last time. Time before, whatever. Scatter plot would work. Scatter plot. How about qualitative data?
Pie chart.
Pie chart. What else? We just looked at one a second ago.
Bar graph.
Bar graph or
bar graph.
a Pareto chart. Either one. You could put bar graph, that's not wrong. Number 2, what's the advantage of using a stem and leaf plot instead of a histogram? What's the advantage of using a stem and leaf plot? What do you see on the stem and leaf plot you don't see on a histogram? All the numbers.
38.
All the numbers. So number 2, you see all the numbers on
That. I lost too. I ain't getting him in. I ain't letting him
Who is
in.
it?
Sean, you won. You go get it.
Is it Jake?
Yeah.
He just threw his cards.
You won.
He put his cards.
wait for no minutes.
What?
10 more minutes.
I didn't mean to.
And I would've had 8 minutes.
Dude, I'm
You made a bet every time you've been here.
You had a bet?
Yeah.
All of you?
Who won? Sean.
I don't know, how do we do this now?
Not Riley.
Nobody got exact. Do we go to just the closest then?
I think Riley won it.
Go with Riley?
Yeah, you won.
Should've texted me.
I did.
I didn't take it right at that time.
I did text you.
No, you said, send me that homework.
Nah.
That's what you said.
Nah, I said exactly what it is. Come in at exactly 8:46.
You never said that.
It's in the group chat.
Let me see it. It's all
That
right.
was cheating. I'm gonna have to watch you with your phone now, aren't I, Dom? You cheating, trying to. And here I was getting ready to say, you know what? I'll give all of you M&Ms.
I'm fine, bro.
But now I,
Hey, I won't take them. I got paper to write
You
in.
had one for Bree too?
Yeah.
We didn't figure she'd show up. Dalton. Looks like Dalton. Yeah, I think Dalton's gonna win the Bree.
think.
Yeah, I don't think she should.
You can do right
She's only here till 10:18. I'll come in.
She's only here till when?
10:08.
She comes for 2 blocks and then she's gone. Number 2. We're doing this assignment, Jacob. You know, they don't seem real encouraged to do it, so.
I have to. This is like.
What is an advantage of stem and leaf plot? What do we say? Over a histogram. See all the numbers. What's a disadvantage of a stem and leaf plot? It's bigger. Maybe it takes more time. You gotta order everything and stuff. Number 3, in terms of displaying data, how is a stem and leaf plot similar to a dot plot? Well, it's got numbers. Goes in order, something like that maybe. How's a Pareto chart different from a standard vertical bar graph?
It goes, highest to lowest.
Highest to lowest.
Bars go.
Wow.
Bars go highest to lowest, and a bar graph doesn't have to. Five, 6, 7, and 8. You're gonna match 5. All you're gonna have to do on number 5 is put like A, B, C, or D. Number 5. Which one of those does it go with? I can get rid of 1 right away. Ages and years. If you look at the key there, somebody gonna be 0.8 years, you gonna deal with that? Probably not, right? Grade point averages, let's see, A is time it takes a sample of employees to drive to work. Yeah, maybe. Grade point average of a sample of students with finance majors. Could that be the grade point averages? Yeah, 0 to 4, maybe, so let's keep B in mind, that might be. Top speeds, sample of high performance sports cars, 0.8 miles per hour, is that gonna be the top speed of a sports car? Probably not. Alright, so probably number 5 would be which one? B probably. Number 6. Looks like we go from like 67 to 94. Which one do you think that is? A, time, takes sample employees to drive to work.
I'm going with D.
D, ages of a sample of residents in a retirement home. That could be 94. Don't be putting the kibosh on me. I don't want to live 40 more years or so.
My grandma turns 90 this year.
Then why you-
Sweet.
So I would probably, number 6, I'd probably go with D on that one. Number 7, we're looking at those numbers, we go from 5 to about 37. Top speeds or time to drive to work. A. A for number 7, then number 8, does that fit the top speeds? Yeah, 205 to 217. 9 through 12. Use a stem and leaf plot or dot plot to list the actual data entries. What is the maximum data entry? What is the minimum data entry? I really don't care if you list all those out, but let's do the maximum and minimum at least. For number 9, what's the minimum? 27. What's the maximum? 85. Be careful on number 10. Number 10, what's the minimum? Look at the key.
12.
No 12 in there, because it doesn't have anything in the stems. 12.9. 12.9 would be the minimum. What's the maximum?
167.
Look at the key again. Look at the key again.
1.
Use it to find the maximum. You guys are sort of right with the 167, but what do you forget? This is where people have trouble with stem and leaf plots if the key's not exactly what you're thinking it should be.
168.
What do you have to put in there? Thank you. 16.7, so now I was getting tired of saying all these numbers and it wasn't that difficult. 16.7. What's the minimum for the dot plot on number 11? 13. What's the maximum? 19. Be careful on this one. What's the minimum on number 12? To what?
215.
214 it looks like. 215 actually goes with that next tick mark. What's the maximum? $239. Good. Do we want to go back over 13? No. 14. Tell me something you can tell from that time series there. Alright, motor vehicle thefts are going down. Let's just say something about that. Why do you think motor vehicle thefts are going down? Do what? Security's going up there. They're probably harder to steal, right? A lot of cars now, if you don't have the correct key and stuff, the car won't start anyway.
Some of the new cars, if you put the key in the door, it goes to the beepers on.
Yeah.
I think that's stupid.
How about 15? Give me something you can say about 15.
New cars, if you put
How other drivers irk us. Okay, that might be one thing. A lot of things upset us driving. What looks like it bothers people the most. Maybe there's something tailgating, right? That bothers me to no end. I hate it when somebody, if you don't like how slow I drive, then pass me. Don't.
I hate it when people pass me.
I like people to pass me, get away from me.
I'm flying anyway.
Because you're probably an idiot driver, and I'd rather you were way up the road, and when you crash, I can go by and I go, you're a moron. That's how it's easy. So Grant could fly by me, and
I don't pass people though.
I get up the road 2 miles.
No, I
and Grant's in the ditch again.
never once passed somebody.
No, I remember when he, Wade, Dustin, like, filed.
He was coming back from
Found
CTC,
him.
he was like, a 3-car pileup? And then we realized it was all national trail kids.
Yeah.
We all drove
I was
by.
right behind there, and then Mr. Wendell was behind me. It was so funny. You like drive by, like, you go okay? Yeah. It's hilarious.
And then Austin Rao.
Driving and cell phone use number 16.
You're fishing on this.
Give me something you could say about number 16. What happens most when you driving using the cell phone? People swerve. I was coming home from Columbus the other day, and I don't know what this person was doing, but it's outside of Columbus. It switches. 70 goes this way, and 270 goes this way, and there's 2 lanes going each way. And I'm in this lane, and I watch, and there's nobody trying to get over anything, and I couldn't get over because there was another truck there next to me. And all of a sudden, this woman comes up, and she's like, you know how when things switch, there's a little V there that you're not supposed to drive on? She's driving in that. And I didn't see her until she got right up next to me. And she's like still trying to pass me. And then all of a sudden, there wasn't going to be room for her to pass me, so what'd she do? I slammed on my brakes and about hit the truck that was next to me and stuff, and it was like she didn't even do anything wrong. I'm thinking, you
Should've let her hit you. You would've got a new car.
I was going about 60 miles an hour. I didn't want her to hit me.
Hey, you can get some money from that.
I'd probably be dead.
That's a face
I can't get no money if I'm dead.
That's a big face.
Your family does.
It's a face.
They were with me. They'd be dead too.
Oh, and one of them are gonna survive.
Oh, yeah, we do.
Alright.
Bring a coffee pot. Keep filling it up all day.
We're out, baby. So tired. Been a long week.
Just walking in Mr. A's with the comic, I can just like see what happens.
Working or something, or what?
Comic playing or
Okay, then that way.
Still need that homework.
Why do you trying to be like the rest of Be one of the big dogs.
I didn't even think about it. I figured
So at first, they were like,
This is warm milk.
You know how when you 40 in the race now, like
my son wanted to get his out and not too Sean, just keep that with you.
Okay.
And it started pouring down. I said, they're going to cancel it. And I see lightning. And I said, they're going to cancel it. And he was all mad because I just went on home.
I wanted to quit because I was like, I'm not really in the mood now since we're just sitting here for 2 hours.
I was at work. Sorry.
It was nasty. We were at my youngest son's football practice, and I'm sitting there in the van, and you could just see it. It was nice above us, and
And you see
over in
the
the
rain
distance,
coming
you
at
could
you.
just see a wall of rain going.
Yeah, I saw one time and I didn't see it. I'm like, what is that? I was like, and I was building a deck and it just all hit me. Dang, I'm like, what was back there?
22nd, if you're a senior and thinking about attending college, it is recommended you sign up for this test. Check your email for details and see Ms. Dubrow if you have any questions. Tonight is an orange out at the football game. So everyone come decked out in your orange attire and support your football team. We saw quite a few students today with their orange, and we really appreciate that. Sophomore class officers need to meet in Miss Terrell's room 219 at the beginning of intervention day for a brief meeting. So today, Project Wisdom. As a young person, you may feel that we are powerless to do anything really grand and wonderful in the world. Well, think again. Did you know that the state flag of Alaska was designed by students? That the first synthetic dye was made by an 18-year-old boy? That Superman was created by 2 teenagers? It was once said success is achieving the maximum of your potential in the situation that you are in. Today, remember this. Whatever the circumstances of your life, you absolutely have the potential to do something grand and wonderful in the world. And though I have not forgotten, at this time, please stand for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. So a reminder, tonight, football game against Twin Valley South. We will look to see the Blazers take them out for their first win tonight. And with that stated, that concludes the announcements for today. And so have a great day and go.
got his money.
Jack, the apartment. I think last year.
Hell, they started making it where, but last year it did look like people started parking, because we used to park in that lot down there right next to that truck stop all the time and just walk down instead of paying for parking. But there, for a while, it looked like they weren't letting people park over there anymore. But then last year, it looked like there was some people going in there again. Right. And then you'd wish, why didn't I go ahead and pay the $10 to park or whatever?
Well, you stop and think about it. You can't park anywhere. When we go to, cause they got downtown day now, when I think River Valley and all that stuff, it's neat.
I know, like Ohio State is $20 to park when you go to a game there, and I went down last weekend to sit and watch the game with him, and I parked in one of the parking garages, because all the parking garages, they actually use for the games, except for one. And they don't let people in unless you're there to visit somebody, supposedly. They got two young black kids standing there. You here to visit somebody in the hospital? Yeah. Oh, okay. And they let you in. Like, really? So if that's all I gotta do, I can come up here and I can park for free during the Ohio State game if I take you off at the hospital, because you know there's people who go in there and lie to them and say, yeah, and they figure that out and they park for free and it's closer to the stadium and save $20. But
Yeah, I would like, what I did, was up that side there. I don't know.
it's,
That was 86,000 and, about another 20 on top of
yeah,
that.
110, yeah, something like that.
Yeah. I made really good time last year.
Yeah.
So, I made great time, and I've heard of Stead was way over in Columbus. Then after I got off the interstate, it took me an hour to get. And I mean, I'd sit through probably 3 or 4 green lights before I could get to the intersection, because people would be turning and get up there and nobody. I was ready to strangle somebody. And then, when I got there, they nailed me for 15 to park in this parking lot, which I am not exaggerating, it was a mile away from the stadium. It took us probably 15, 20 minutes to walk to the stadium, and I went walking slow.
That's
It
usually
was like, we missed the first 25, 30 minutes. of
Well,
that.
that's usually where me and Ben park, because we usually park out there pretty far, because I hate being in the traffic, so I just say, screw this, I'm gonna buy all this. We'll park down here and there ain't nobody in that lot, and, because sometimes we park in lots where guys taking the money, and I'm thinking, you know what, I don't know if this is really his lot or not. He might just be standing at somebody's lot taking money, and, because we parked so far out normally, but this last time it took, I got up there, my GPS said that I should be in Columbus at, like 9:05 on this past Saturday, 3 hours before the game. So I get up there, I get to 3:15, got off the interstate, got on 3:15, and from the time I got on 3:15 to get to the hospital, which is about maybe a mile, might be a mile and a half, because it's the second exit once you get off 3:15. It took me about 55 minutes. So it took me about 55 minutes to get, or about, it took me longer than about an hour and 20 minutes to get to there, and another 55 to get that last mile and a half, because it was so ridiculous.
That's what it is.
And there wasn't no reason that if you go, and this might not be the greatest thing,
Restarting the computer worked.
Okay.
Thank you.
if you go and you pass all those exits, Lane and Ackerman and all those, and you go on down, and you get back on 315, coming back the other way, and get off on like Olentangy, because finally I got fed up, and that's what I did. I said, screw this, I'm going on north, and I'll get up here and then I'll turn around and I'll find my way back on the city streets. I would no traffic. I mean, I drove down the whole Tangian Tree.
I went to where Lon told me, I didn't even do.
Oh, you didn't?
I don't know what it was, but I just got directions from him.
Probably Broad Street. You know,
Yeah,
Broad Street.
it was a nightmare. It wasn't.
That one side of Broad Street, me and TJ, or me and Ben, one time we met. There's a section of Broad Street there that's not the nicest area in.
I mean, I told the boys, I said, as orders like going along, I said, but also they, I mean, they got their smartphones out, we're like 2 miles on this road. You gotta see a place to park, I won't yell because I'm gonna park, we'll walk. Three College, I know I can walk, but Three College, you just can't, need something wrong anyway. It's like, if we'd have got there faster, we would've.
And usually after the game, that's, me and Ben always park way far away. Usually that helps after the game, because then by the time you get to your car, everybody else is gone. Yeah.
They can get into the stadium, people are just like, fight the crowd, and you gotta play for years to be up there.
Yeah.
I'll never do it, I won't, I'll watch it on TV, it's, if I just need to, I'll go to meetings, drink bourbon barrel, watch it on the TV,
Yeah, Stan sends me his prices on his OSU tickets every year, and I told him before he retired, I said, unless it's the Ohio State Michigan game or some other big game like that, I ain't buying no more tickets. I don't feel like being around 110,000 people. It's just, it's ridiculous.
I am getting, you know, when we first started doing big games, I love it. I go, I'm getting old enough now. I don't know that I care for them as much, not like I used to. I mean,
Yeah.
I still get into it when they're playing well and stuff, but. I'm getting bad.
And the UD games get worse because now it seems like everybody that's there, they're standing out there in that little hallway just drinking. They ain't doing nothing else.
Yeah.
They're standing out there getting drunk. You go down 5 minutes into the game to go to the bathroom, they're still all down there.
Not even there to watch the game. Yeah, I don't know. I mean, I do like see the boys and stuff, so I mean, right now, that's good. Otherwise I wouldn't see them going for that. But just the older I get, the worse I get. I'm like a Christmas shopping. I order everything. Sit to the house.
Usually I go like real late at night somewhere. It'd be 11 o'clock at night and I'm going through Walmart or somewhere looking for stuff. Did you guys play last night?
Yeah, we lost it, nothing.
So you guys didn't get it? You didn't.
We ended up playing 2 20-minute halves, and the boys played 1 full half. Because then they canceled it, but then they saw no need, so they figured we could just try and get
Put it back
as
up.
much as we could. Hey, I'm sorry, I had to run down and make some copies and Tom was